AP exam, you're going to need to be able to predict reactions. So you'll be given a couple words, and you'll need to first write out what the reactants are, and then predict the products, and then write a net ionic form, which is also balanced. Okay, so one very, very common type of reaction is the metal displacement, or actually any single displacement, either metal, hydrogen, or halogen. So first, the metal displacement. Here, you are reacting some metal with some metallic ion. So, for example, react a zinc solid with copper sulfate solution. So that will very often switch the two metals. You can then get, let's see, copper by itself and zinc sulfate. Now, why do I have only one zinc here instead of 2 or 3? Zinc is 2+ if it's charged, and sulfate is 2-. All right, so you'll need to write this in complete ionic form. So take your aqueous compounds. So let's see, we have copper ion. We also have sulfate, and then we have copper solid now, and zinc ion, which is aqueous sulfate, and sulfate here. Okay, and now you can cross out the spectators, and that will leave you your net ionic form. So you get copper solid, and you get zinc ion. Okay, so why do I have copper here with no charge and zinc actually with the charge, whereas before they didn't? They had no charge or a charge. There's actually an oxidation-reduction going on. You see, that zinc is actually quite reactive. Let's look at the activity series here. Zinc is quite reactive. It's quite high up on the activity series, whereas copper not so much. Zinc has a high ability to be oxidized or to reduce something. It's a strong reducing agent relative to copper, and so zinc and copper ion can kind of switch places, so that copper will soon be the solid, and zinc ion will be left. This reaction is able to occur because copper is fairly stable, having no charge. So what's really going on here is you're putting your zinc solid into solution, and you'll see that pretty soon it pretty much dissolves. There's a lot of the blue copper sulfate ions here actually being absorbed onto that solid. Really what's going on is zinc solid is turning into zinc ion and dissolving because it's giving off 2 electrons to the copper ion to form copper solid. Soon a lot of that zinc has dissolved, and the copper ion in solution has turned into solid. So again, this reaction occurs. This oxidizing of zinc and reducing of copper metal, this is occurring because basically the guys higher up here, they are more reactive in the activity series, the guys high up in the activity series, and the guys down low, they're fairly stable. So it's preferable and stabilizing for the whole system to get stable copper, silver, platinum, gold, metal. Note actually that a lot of these guys down here, they are quite valuable, generally because they don't react very easily. They will remain in that shiny, solid form. So you can have silver coins or gold coins, which remain as fairly unreactive solids. Now, So I guess we're able to switch zinc solid with copper ion and get zinc ion and copper solid. But what if you were to try to put silver metal into copper sulfate solution? Well, you have silver here and you have copper ion. Now, I would just ask myself, hey, which of these metals is more stable, silver or copper? Well, the lower you are, the more stable you are. So silver is more stable. It's fairly unreactive. It's not likely to react into silver ion. So you can say then that this reaction between silver and copper sulfate really just won't occur. But all these things also apply to hydrogen displacement as well. So hydrogen displacement. You can actually look at the activity series and you can see that these guys pretty high up, they're more reactive, right? In fact, they are able to remove hydrogen even from cold water. These guys in the middle, they're not able to remove it from cold water, but they can remove a hydrogen from hot water, steam. And these guys who are a little bit less reactive, they're not able to remove hydrogen at all from water, but they are able to do it just from acid. So these guys can do cold water and acid. These guys can do hot water and acid. And these guys can only do acid. Everyone below hydrogen here is unable to react with either water or acid. So take a look at putting sodium solid into water, cold water, i.e. in a lake. So if you throw it into a lake, will this sodium up here, fairly reactive, react with the water? Actually, sure. It will react with cold water, hot water, or acid, because it's much, much higher than hydrogen here in the activity series. And so you will have a displacement in which that sodium can switch with the hydrogen, and so you'll get hydrogen alone, and you'll get, let's see, sodium combining with hydroxide, sodium hydroxide. But to improve this, sodium hydroxide in water now is going to be aqueous, and hydrogen alone, that's H2. And that's a gas. Now let's write this in the net ionic form. Let's see, so you get sodium solid, you get water. It's best that you probably write H2O. You get hydrogen, and you get separate sodium and hydroxide ions. Hey, you would get gas bubbles released if you threw sodium into a lake, but you would also make the lake a little bit caustic or basic. That would probably kill some fish. Don't do that. Next, would you be able to react magnesium ribbon with hydrochloric acid if you dropped it into hydrochloric acid? Well, magnesium, you can see magnesium up here. Here it is. It's quite reactive. It can react with either hot water or with acid. So you'll see that you should be able to form, let's see, switch magnesium with the hydrogen, you'll get H2, and you'll get magnesium chloride, MgCl2, and then you could write that in net ionic form. Would you be able to react, say, oh, I don't know, silver with hydrochloric acid? Nope. Silver is below hydrogen in the activity series, so there's no reaction there. Try halogen displacement. Okay, so the most reactive halogen is actually the one highest up in the periodic table, fluorine. Then chlorine, bromine, and iodine. Test this problem. Chlorine gas, can it react with potassium bromide as it's bubbled through solution? Can chlorine replace bromide and form bromine? Well, if you were to have this reaction, actually the chlorine would switch to the other halide, bromine, and you would get Br2 and KCl. So is it possible to switch Cl2 with Br2? I'd say yes. Bromine is more stable than chlorine. I think that the whole system would appreciate having a more stable compound, bromine instead of chlorine. So yes, this reaction will occur. Try another one. Can iodine react with potassium chloride? Iodine reacts with potassium chloride. So iodine would switch with the chlorine there and form Cl2 and Ki. Can you replace the I2 with Cl2? Is that preferable for the system? No. You're taking something that's very stable and forming something quite unstable or highly reactive. That is destabilized into the system. No reaction there. Finally, disproportionation reactions. So take hydrogen peroxide. You see, the oxygen there, it has oxidation state of -1. But if you heat this, you can actually get dihydrogen monoxide water, and you can also get oxygen gas. Now, the oxidation numbers of oxygen here are either -2 or 0. Here in this case, oxygen, it's turning from -1 into -2. So one of the oxygens is being reduced, and another one is being oxidized. Disproportionation means that element is being both oxidized and reduced. So as another example, Cl2 reacts with hydroxide. Cl2, it went from 0 to -1 or to +1. All right, thanks for watching, guys.